Hello, so this is going to be a quick demo of my new procedurally generated dungeon tool. So I'm going to trigger the creation of the dungeon. Okay, so it has walked through the dungeon and placed various parts. It's just rotating them now to make them all aligned, and there we go. Okay, so we'll have a quick run through the dungeon. So this is basically walking through the dungeon, connecting all of these blocks together in a similar way if you've played Warframe or Diablo. Yeah, there's not a huge amount to say, so this is all the connected parts. So we'll just get to the end and then save the output of this dungeon. Right, so there's the end of this dungeon. So everything you see on screen, all these walls, the lights, the pillars, everything was placed dynamically. So there was nothing preloaded here. So you can see the map of our dungeon. It's gone back over itself a little, but that's not a problem. So next we have this little tool called Capture Area. So if I run that, freeze for a second and then save it to an external file. So we're done with Skyrim for now. So if we open up our logs folder, you can see there is the Undaunted Rift pass file. So that is a script that contains the positions and rotations and scale of all the objects, as you can see here. So what we're going to do is we're just going to give this a friendly name. So the code doesn't name the cells, so it's useful to have them separate. So we're going to say Rift demo. Okay, save that. So this pass file is a SSE edit script. So what I'm going to do is I'm going to apply that script file to my mod Undaunted. So this was built in Mundusform and I'm able to apply it to a separate mod. So apply script. So you see Undaunted Rift and it's Rift demo. So apply that. Okay, so you can see we got a new cell here with all the parts in it. So save that out. Okay, so now Undaunted has a new cell created based on the information that was captured after the generation process. So we'll get Undaunted open. You should see Rift demo. Yep, here we are. So this is the dungeon that was generated. I think yeah, you can kind of see it went back on itself a bit. That's not ideal, but it's randomly generated. There is tools to prevent overlaps, but there's still a work in progress because it's quite a complicated area. But it did pretty decent. I don't think there's any glaring errors. So as you can see, it starts at the entrance and then it walks through each of these blocks, placing them, and each block has multiple exits. So you can see this is a square block here. This is a four-way block, so it has 3 exits. So it's picked an end cap for this one, a wall for this one, and a ramp for this one. So what it will do is it will go through each tile and place the next, kind of creating a main path until it gets to the exit, and then it'll go back and fill in with side rooms and blocking off and stuff. Okay, so that's all very well and good. People have done things where you've placed cells before, placed objects randomly. So this tool by itself isn't massively new, but there is one feature that is quite new. So if I just turn on nav meshes, you can see that the dungeon actually also generated a nav mesh. So each of the blocks has information about the nav mesh that's required for that block. and as it's placing, it's updating and doing everything. So let's get this in game. So first thing I need to do is make a small edit. Okay, save that. So that fleshes out the information in the Navmesh. Next I'm going to do a balance pass. Basically I'll just simplify the Navmesh. If you've watched my other video, this will seem very familiar because the tool is the exact same. Okay, so I'll save that out. Okay, so we're in 0 Rift demo. So that's it. That's the mesh is now ready for use in game. So you can see that having the nav mesh generated with the cells is critical, because of the amount of time that saves. So we'll get into game. I'll show you the Rift, and then we will talk about how it's done and what the next steps are. So teleport to Rift demo. Okay, here we are in Rift demo. I've got Sophia with me again, and you can see that. So the lighting's changed because it's set a light set world cell light details or something like that. You know what I mean? If you've done any editor stuff. So go up ramps. So as you can see, Sophia's fairly happy to follow us around. Yeah, so now we have a completely nav meshed dungeon, generated rather quickly. Oops, started a bounty. Yeah, so okay, so that worked. You can see that generated a dungeon with a working nav mesh. So I'll quickly go over how that actually works. So basically we have this concept of blocks in Mundusform. So a block is a piece of dungeon. So the most basic one is a simple hallway. So we've got various information here that we need to build out this block. So I'll go through it. So first off, we have the type. So it works in a kind of entrance, hall, room, end, and exit are the types, and those are used in different ways to build up the map. So a hall is a connecting piece between two rooms. We've got the bounding box, which is an attempt to stop overlaps. Next we have the name of the entrance. So this is the between each of the blocks is a connector piece. The connector piece needs to know where it is. So by default I've been using 000 because that makes it easier, and also what type it is. So that prevents blocks of, say, a keep connecting to a block of a Dwemer without a specific adapter. So everything at the minute is this Dwemer facade hall small. But if you have a set of blocks for, say, the keep, you can have those alongside, and the generation tool will not connect blocks of different types. You can make your own block, which starts as one thing and ends as another thing, but that's up to the user. Next is a list of the objects that contain this. So this only has the straight hallway piece, position, rotation, and scale. Next is the Navmesh map. So this represents the Navmesh for this one block. So what happens is every time a block is placed, the Navmesh is added to the system, and then at the end it's all joined up. And then finally we have the exits. So this is where a passageway leading out from this cell is. So you can see here we've got a small hallway exit at 512 in the y-axis. Yeah, so you can see this allows pretty much a lot of flexibility. So we can have different connectors, different forms, and multiple exits. So I'm going to show you so if we go to the four-way, you can see it has 3 exits. Currently it randomly when it's doing the main branch, it randomly selects one of the exits. Oh yeah, the one over. Okay, so you can see here this last number is changed as well. This is the rotation. So each block is pivoted around the entrance, so you only have to declare a block once, and it'll rotate in the cardinal directions for you. So you don't need to have multiple, like corridor going north, corridor going east, corridor going south, etc. Yeah, so this has multiple exits. It'll select a random one when building the main path, and then if we go to the room, so this is the big room we were walking through, you can see you can have multiple different objects in a room, including lights and stuff like that. A big nav mesh, and then the exit. Yeah, so you can see that entire dungeon was generated from these files. Obviously, adding to this list, this block library, is the main kind of next step. I've written some tools for gathering this information. I won't go through it in this video, but yeah, once it's a work in progress, and I think most of the hard issues have been solved. So yeah, tell me what you think in the comments or the Reddit thread, and I'll continue working on this. Thanks for your time.